Okay, I'm back. All right, the segment addition postulate. Your key is to draw, and this is what you draw. Right here, given that B is between A and C. So you draw what they give you. Okay, so they say B is between A and C. It says AB, the distance between AB is 5.3. So this distance right here is 5.3. And it says AC is 6.7. So this whole distance is 6.7. So the distance I'm looking for is actually BC. So we're looking for a part. So after you're done drawing and labeling, now it's your turn to write a equation. So we have AB plus BC equals AC. Well, AB is 5.3. We don't know BC, so we're going to label it with X. And then AC is 6.7. Well, now we just solve for X, which in this case, we're going to subtract 5.3. Okay. And 6.7 minus 5.3 is 1.4. So X equals 1.4. All right, same thing for number 20 and 21. Okay, but I'm going to kind of start you on number 21. It's the same picture. It says that if B is between A and C. So the key is to draw your picture. Okay, it says that AB is 3 times X plus 7. And BC is 2 times X minus 3. And then AC, the whole segment, equals 50. Okay, so now it's the same thing. We're going to set up our equation. Okay, so it's AB plus BC equals AC. Well, AB is 3 times X plus 7, so we have 3 times X plus 7 plus BC, which is 2 times X minus 3. So we're going to plug in 2 times X minus 3 equals AC, which is just 50. Okay. All right, so I'm not going to solve this the rest of the way out, but your first step, because we have parentheses, we have to distribute this 3. We have to distribute this 3 to everything. So we have 3 times X, so 3X times 3 times 7, which is 21. And then 2 times X, which is 2X. And then 2 times negative 3, which is negative 6, equals 50. All right, so you're solving for X and plugging into BC, which is 2 times X minus 3. All right. All right, distance formula. Okay, so you can either use the actual distance formula that I have written right here, or you can use Pythagorean theorem using the graphs. So I'm going to do an example of doing the distance formula. Either way, it's the same thing, okay? So your first step should always be to label your points. So we have x1, y1, x2, and y2. And now we just plug into our formula. So our x2 is 2. So we're writing 2 minus our x1, which is 3. Close the parentheses and square it. Plus our y2, which is 4, minus r y1, which is 1. Close the parentheses and square it. So now we do PEMDAS from here on out. So PEMDAS. Okay? So we're going to keep the square root, but we're going to solve the parentheses first because that's what is first. So we have 2 minus 3, which gives us a negative 1 squared, plus a 4 minus 3, which gets us a 3 squared. All right, next thing is exponents. Okay, so we're going to take care of those exponents. So negative 1 times negative 1 is just a positive 1. Keep the addition sign, and 3 times 3 is 9. Okay, now we don't have any multiplication or division, but we do have some adding, so we're going to add. So 1 plus 9 is 10. And then now we can actually take the square root, which the square root of 10 is 3.16. So we take the square root of 10, which it gets us approximately 3.16, but it says round to the nearest tenth. So we're going to erase that because that's not the nearest tenth. And we're going to say 3.2. Okay. Remember how you do the Pythagorean theorem? You plot these points. So number 1 is to plot your point. So we have 3, 1. And we have 2, 4. Okay, so you have to create a triangle. So step 2 is create triangle. And it has to be a right triangle. Okay, because what I'm highlighting and what I'm crossing in black is the distance you want to find. And then now we can set up our Pythagorean theorem. So we have three units right here and 1 unit here. Well, remember Pythagorean theorem is a squared plus b squared equals c squared. A squared and b squared being the sides of the triangle, the legs of the triangle. So we have 3 squared plus 1 squared equals c squared. 3 squared is 9 plus 1 squared is 1 equals c squared. Then we have 9 plus 1 is 10 equals c squared. Take the square root to get c by itself, and you get the same answer, 3.16. That is not a 1/6. Okay, so either way works. So your step 4 would be to solve for C. All right, midpoint on a number line. We have this beautiful formula right here that we need to utilize. Okay, so A and B being our points that we're using. So midpoint equals A plus B, which A is -2, plus 6, which is B, divided by 2. You must solve the top first. Solve the top first. Okay, so the top ends up being 4, -2 plus 6 equals 4 divided by 2. And now you can divide by 2. Okay, now you can divide by 2. Which 4 divided by 2 is 2, so your midpoint is 2. All right, so coordinate plane segment midpoint. All right, so same thing. It's the same thing as up here, but now we just have to do it twice. Okay, but we have x1, x2, y1, y2. Okay, just label your points. Label your points. So we have x1 and y1 and x2 and y2. Okay, now we just set it up into this formula. So midpoint equals x1, which is 0, plus x2, which is 2, divided by 2, comma, y1, which is 0, plus y2, which is 5, divided by 2. Okay, so now we just, again, solve the top and then divide by 2. So we're going to solve the top first. So we have midpoint equals 0 plus 2, which is 2, divided by 2. And 0 plus 5, which is 5, divided by 2. Okay, and then now we can simplify those. So the midpoint equals 2 divided by 2 is 1. And then 5 divided by 2 is 2.5. So the midpoint here is 1, 2.5. So don't get confused here. You do not multiply these two numbers together. You do not add them. You do not subtract them. You do not divide them. I want two separate numbers because we are on a coordinate plane, which always involves two numbers because they're coordinates. All right, so this one I'm gonna give you a hint. There's a reason why you have a coordinate plane. So it says, given that B is the midpoint. So B is your midpoint. Okay? So that means we are finding endpoint. So remember, when we're finding endpoint, there is a step that we can do. Okay, so we have to plot our points first. So we have -5, 1. B is -2, 0. Okay, and remember B is your midpoint, so I'm going to highlight it. All right, so once you're done plotting your points, you need to count slope. I'm going to zoom in a little bit. You need to count slope. So our slope here is we go down 1 and then to the right 1, 2, 3. And now we repeat slope going from our midpoint, point B, to our other endpoint. So point B counting to our other endpoint, which is point C. So we go down 1 and then over to the right 3. And then now we just count the coordinates. So then we just count coordinates of point C. So from 0, I go to the right 1 and down 1. So the coordinates here. So for point C, I went to the right 1, so 1, down 1, so -1. So the midpoint here, or the other endpoint, is 1, -1. Okay. You will have a question like that on your test. So whether you solve it algebraically or graphically, I don't care. All right, your last two questions. Okay. All right, when you see the word bisector, there's two things that are going to happen. You're going to be given two parts. So the first thing that might happen, you're going to give two parts. If you are given two parts, set them equal to each other. Okay, the second thing that's going to happen is they're going to give you one part and one whole. Okay, that's the question I'm going to do here because I think we're still not understanding how to set that up. So number 1, let me show number 29. Okay, so number 29, it says AD. Okay, first it says in the figure below, CD bisects AB at D. So the word bisects tells us that these two segments right here are congruent. And I'm telling myself that they're congruent by writing those tick marks. So what we are telling ourselves is that AD is congruent to DB. All right, well, if AD is congruent to DB, all I need to do is set those values equal to each other because look in your problem. They have given you AD and then they have given you dB, which we just stated were congruent to each other. So AD is 2x plus 11, and we're going to set it equal to 4x minus 5 because AD is equal to dB. Okay, and you solve for x, and you're going to plug it into AB. So AB is the whole segment. So you need to plug it into both and then add them together because AD plus DB equals AB. So you're going to plug it into 2x plus 11 plus 4x minus 5, and then it'll get us AB. Okay? So, no, that's not the answer. I'm not giving you the answer for number 29 because I think you're able to solve it. I'm going to do the number 30 because I feel like we're still getting confused on this one. Okay? So, for number 29, you need to solve for x here. Put my x answer right there and then plug it into this formula to find AB. So it'd be 2, whatever you get for x, plus 11, plus 4 times whatever you get for x, minus 5. And that'll get us AB. All right. So for this next one, it says that AB is 5x minus 4. So this whole thing is 5x minus 4. So I'm going to write 5x minus 4. Okay, so this is what I'm writing is for number 30. It says that dB, actually go back. Write it in blue because it's already highlighted in blue, is x plus 1. So this little section right here is x plus 1. Okay, so we've already stated that AD equals dB. Okay. All right. But it gives us a whole. Okay. So anytime it gives us a whole, we have to do part plus part equals whole. Anytime it gives us a whole, we are going to do part plus part equals whole. Okay? All right, but we only have one part. Okay, so notice that we only have one part. We only have x plus 1. But the term bisector allows us to do one thing. Okay, if we only have one part and then a whole, and we don't know what our other part is, because of the term bisector, we can also label AD as x plus 1 because since dB equals x plus 1, I'm going to plug in dB for x plus 1 or x plus 1 for dB. Well, look at there. It says that AD equals x plus 1. So now I can take this and label this part. So now I have a part plus part equals whole. Now I have a part plus part equals whole. So our part plus part equals whole is now AD plus DB equals AB, which we stated up here. We stated right here. Okay, so our AD, which we are now able to label x plus 1, so we're going to plug in x plus 1, plus our dB, which is x plus 1, equals our AB, which is 5x minus 4. All right, so now we just solve for x. So we're solving for x. So we're going to combine like terms. So I have an x, another x, so I have 2x, and then I have a positive 1 and another positive 1, so I have a positive 2 equals 5x minus 4. I'm going to draw my railroad track. All right, I have x's on both sides. So I got to get rid of my x's. I need to move one of my x's over. So because 2x is my smallest x, I'm going to subtract 2x over to the 5x. I have 2 equals 5 minus 2 is 3. So I have 3x minus 4. All right, so because my x's are on my right side, nothing else can be on my right side. So I need to add 4. 2 plus 4 equals 6, equals 3x. All right, so last but not least, your last step should always be to divide whatever is multiplying with the x. So right now a 3 is multiplying with the x, so I need to divide by 3. So when I divide by 3, 6 divided by 3 equals 2. So our x is 2. That means our AD, which remember is labeled with x plus 1, is now 2 plus 1, which is 3. Okay, I hope this helps. If you have any more questions, let me know.